Okay, in this video what we're going to discuss is so-called U-Substitution from integral calculus. I presume that you are either currently taking it, and maybe you don't quite always know how to choose a U, or you previously took it and you're trying to remember it for some reason. Anyway, so how does one go about choosing a U? Now, to be sure, there is a bit of guesswork in it, but one thing that's very useful to keep in mind while working through this is the chain rule. So what do I mean? Okay. You have some integral, in this case, this one, and you have a candidate substitution that you would like to make. So I want to say, make u, I'm going to let that be 2x plus 1. Okay, because I'm thinking chain rule, it follows that the question I need to ask myself is, the function I just chose, is a portion of its derivative floating around anywhere else in the integrand? Apart from where I'm just choosing it from. So in this case, apart from the radical here. And that's without paying attention to a constant function. So in this case, what I'm asking myself is, with respect to the x here, is any part of its derivative floating around anywhere else in this integrand? And clearly, well, not clearly, it's invisible, but yes, there's that magical one we can always multiply. It's there, so I have probably made a good choice. I'm going to point out, some of these problems will have more than one perfectly fine substitution to make, and this happens to be one of those, but the other substitution is not at all obvious, so I'm going to go with this one. Alright, so what it is that I would want to do now is do the actual substitution, and so wherever I find 2x plus 1, I'll replace that with u, and that's going to leave me with the integral of the square root of u. Now the next part is, obviously, because I have a u here, I need to change my dx to a du. I'll differentiate this, so du dx equals 2, and for those of you who are smarter than I am, you can probably just do all that one step in your head, but I'm a little slow, so I need to do it by hand. Put my dx on the other side, and then divide out 2 from both sides, so that way I wind up with the dx equals something. Okay, so now I can make that substitution. Dx is precisely equal to du over 2, which another way to write that, I hope everyone will agree, is 1/2 integral square root u du. And if you don't agree with me, we need to talk. Anyway, so I now have this in that u du form I wanted as opposed to an x dx kind of form. And it seems to be a fairly straightforward integral now. Just 1/2. Integrate that. I'm going to change this to a power. Yes, okay. So add 1 to it, divide by the new thing, so that's going to be u to the 3/2 divided by 3/2 plus c. This is an indefinite integral after all. And I need a little bit more room here. Okay. So now it's a matter of just simplifying this. So this is going to be the same as 2/3 times 1/2. That flips up. U to the 3/2 plus c. I'm going to reduce here. Okay, now it's just a matter of replacing what we originally substituted. So in this case it's going to be 1/3, replace the u with the 2x plus 1 to the 3/2 power plus c. And like good calculus students, we want to check our work to make sure we got that right. Right? We always check our work, don't we? No? Oh, okay. Well, remember I mentioned earlier that one thing we want to keep in mind throughout this whole ordeal is the chain rule. So it should not be surprising that we're going to use the chain rule to check this. Okie dokie. Alright, so the derivative of the outer function evaluated at the inner function times the derivative of the inner function is what we're going to do here, because it's the chain rule with respect to this bit. Okie dokie. So what is that? Evaluated at the inner function, so that's 2x plus 1. Subtract that 1, that's going to be 1/2 times the derivative of the inner function, which is just going to be 2. And then when we differentiate that, it's just going to be plus 0. So let's see what this comes out with. the 3's cancel, so the 2's cancel, and that's going to leave me with 2x plus 1 to the 1/2 power, or the square root of 2x plus 1, which is the very thing that we started off worrying about. And so we know that we have not colossally gone wrong anywhere in here. And because of the wonderful magic of the internet, you didn't have to watch my writing this down. But in the same way, in the first question, the first problem, what we were talking about is thinking about the chain rule when evaluating a prospective U-substitution. So too will that be the case here. So what I want to think about is choosing something that's going to make this simpler, and in that chain rule bit. So again, I'm going to choose the radicand. Okay, now the question I need to ask is there a part of this derivative, the derivative of this, floating around somewhere else in the integrand? The derivative of that is 2x. Hot diggity, it's floating around. So, that works just fine. Okay, we'll go ahead and do this substitution straight away. So, I'm going to rearrange this just a little bit while I do it, but it's going to give me the square root of u, and then, just imagine the 2x dx here being together. Now, this clearly doesn't work because we have a u and x's, and so we need to get these x's here in that du form, so we have the integral of u du. Differentiate this. Put dx on the other side, so that's du equals 2x dx, and now it's just a straightforward substitution. So now we have integral of square root u du, straightforward integration. That's going to give us u to the 3/2 divided by 3/2 plus c. And now we'll just substitute everything back in, so that's what this is going to be 2/3. Okay, so that's the correct, that's the actual integral here. And like good calculus students, we should want to check this, so that's where the chain rule is going to come in. Okay, so I've got my constant out front. I'll try to make it correct. So the derivative of the outer function evaluated the inner times the derivative of the inner function. Okie dokie. So that's going to give me evaluated the inner, 1 plus x squared to the 1/2. And that derivative just goes away, but we need to do 2x. That was not the most articulate I've ever said it. So derivative of the outer function, evaluated at the inner, times the derivative of the inner, and then this plus c just goes away because derivative of a constant is just 0. And now it's a matter of simplifying. So the 3's cancel, 2's cancel, and that's going to leave us with 1 plus x squared to the 1/2 power 2x. Another way to write that is going to be 2x square root 1 plus x squared. And that is indeed the integrand we started with, so we know that we have not gone colossally wrong in this system that I'm proposing to you. I hope you find this useful. Have a great day.